factor the polynomial, the 4-term polynomial, by grouping 2x minus 18 plus xy minus 9y. Now, the first step in factoring any polynomial should be, as a good practice, to look for a greatest common factor. Greatest common factor would be a factor that appears in each of the 4 terms in this 4-term polynomial. So we're going to look for if any common factors exist. In the first term we have a 2 and an x. In the second term we have 2 times 9, or it could be 3 times 6. In either case we wind up with 1, 2, and 2 3's in the 18. The xy is essentially already factored for us, a factor of x and a factor of y. In the last term we have a factor of 9, we give it its own branch, and the variable its own branch. And we're disregarding these signs of the terms for the time being. We'll figure that out later on in the process. So we look for, there's a 2 and an x. I mean, we look at every one of these individual factors at the bottom of each of these individual factor trees, and we find that there is no factor. There are no factors at all in common, other than there's always a factor of positive 1 or negative 1. We could write each of these terms as a product of itself times 1, or the negative of itself times negative 1. So the question is, should we use the negative 1? It's the only one. It's the only of these 2 GCFs that would have anything useful for us. But when we look at the leading term, and presuming that we're going to leave this leading term here where it is, it's already positive. We wouldn't gain any advantage by factoring out the negative 1. So we just disregard. Let's disregard using the GCF in any fashion. So now what we'd like to do is start again with a clean copy of our polynomial 2x minus 18 plus xy minus 9y. So we can get past the factor trees that is basically, we're using that like scrap paper right now. So let's look at even though the instruction tells us to use grouping, factor by grouping, we need to know that given a 4-term polynomial, the method of choice for a 4-term polynomial is factor by grouping. It happens to just be built into this instruction. So here's what factor by grouping asks us to do. We may not have found a useful GCF across all 4 terms, but maybe there's a common factor across the first 2 terms. And sure enough, we find a factor of 2 in common with the first 2 terms looking at our factor trees above, and I don't see any other factors, like the x doesn't appear in the 18 term, the x from the 2x, the 3's don't have any common factors in the first term. So there is a common factor of 2 in the first 2 terms. So we're going to open up a blank for each of the terms 2x and minus 18 and put them in here. We're going to fill out everything we need to make to allow the 2 times each of the contents of these 2 spaces to bring back our 2x and 18. So here's the idea. We always want the first term to be positive. We want to multiply the 2 times everything we've got to put in this blank, signs, numbers, and variables, to make this first term come back. So we're going to figure out that if this term is already a positive 2 and we force this first remaining term to be positive, this 2 would have to be positive, so that positive times positive makes this positive. Here's the first step. Signs are done. The 2 already is apparent, it appears in the common factor. If I had to do a number times a number, the number here would be 1. 2 times 1 makes this 2 come back. I need variables to appear. I need an x in here in the first space. If I check everything, positive 2 times positive 1x makes positive 2x come back. Now we distribute to the second term. What would we need in here to make a negative 18 come back? And we do include in our decision the negative sign. Here's where we include the information that of the negative, the signs of these terms as we go. Positive, I would have to have times negative. Positive times negative makes negative. 2 times 9 makes 18. So this 2 times the contents of this are going to allow the two terms above them to come back. Next thing we need to do, I'm going to take this remaining polynomial from the first two terms after we factor out the positive 2, and we're going to copy it. We're just going to copy it. Copy this binomial underneath the last two terms. This binomial contains a positive 1x in the first blank minus 9 as the second term. Now the question will be, what would we have to place in this blank so that this times this makes all of this come back, this term, and its leading sign? If we start out, we're going to have to have, for satisfy the rules of multiplication, positive times positive makes this positive. This term already has the x factor. What this blank needs is the y factor. So that all of this red plus y times all of this plus 1x, doesn't it make all of this term come back plus xy when we put the variables in order, alphabetical order? Now we distribute the positive y to the negative 9. This content times this content has to make this term come back. Does it when we check? Positive times negative makes negative. Y times 9, that's really 9 times y when we rearrange using the commutative property of multiplication. So what we're looking at now is a common factor. We actually do have a greatest common factor, but it took a little work to find it. It appears here and here. Any factor that appears in multiplication in each term is considered a greatest common factor. Positive 1x minus 9. When we find a greatest common factor, we factor it out once. Now it appears in two places, or two instances of positive 1x minus 9. So we're going to open up an empty blank, two empty spaces, one for each instance of the occurrence of that binomial. And here's how we're going to fill in what we need. The first time we see positive 1x minus 9, it's multiplying a 2. That is going to fill in this blank. It's positive 2. The second time we see positive 1x minus 9, it's multiplying a positive y. That's going to fill in the second blank. When we clean up now all the symbols that we no longer need, positive 1 times x is x minus 9. Positive 2 is a 2 plus y. We're down to two factors. We've accomplished at factoring because the goal of factoring is to find the product of at least two factors. We come up to our possible answer choices and we carefully determine that A has all the proper components of the answer that we determine to be correct.